So, first thing, your unit overview said that the test would be this Wednesday. Well, since we didn't finish this on Friday, we're not reviewing today, which means I can't test you on Wednesday, despite my wanting to.
What about Monday?
I don't do Monday tests. So next Tuesday. Monday tests are the dumbest thing ever. Nobody studies over Easter. Happy belated birthday, Eva. All right. Why not right now? Let's just start it now.
Start what?
Thanks, Eric. All right. We are gonna finish with the Giselle adaptive scores and the age at which kids spoke their first word. So last time we used the computer output to find the equation for our least squared regression line. I give you guys the opportunity to take a picture of a sentence frame for interpreting slope. That's why I don't have anything written. Then we use this information to help us find R. We talked about R is negative because the slope of our line is negative. Then I give you the opportunity to take a picture of the sentence frame for interpreting R, which is why I don't have anything written. Calvin?
Why didn't you put anything for 2?
Interpret the slope, because I put the sentence frame up. Remember? And you guys took the picture. Yeah, I put this up, and I verbally did it. I just didn't write it. And then we talked about R squared. And R squared is new. It's called the coefficient of determination. I don't know why it's called that. And I told you the definition, excuse me, of R squared, and then let you take a picture of a sentence frame for R squared. That's why I didn't write the interpretation. Now we're going to jump down here, and you guys are going to, you should have the data in there. Actually, did I have you type the data in? I can't remember. You need to, if you have the data in there, you're good. If you don't, you need to put it in there. I want you to put the child number doesn't go into the calculator. That's for us in a minute when we're looking at outliers. So list 1 is going to be the age, and then list 2 is the score. So there are 21 children, so you should have 21 pieces of data in list 1 and 21 pieces of data in list 2. So age is list 1. Their aptitude score is list 2. And first thing I want you to do is make a scatter plot, but then we're also going to make a residual plot. So just make sure that you leave enough room to do both. We're working with the packet from last time still. to residual plot. Which hopefully you remember the steps. If you don't, let me know. Yes. So we have our square root.
Yeah. No. The first one, go to white.
When you're gonna find a why
Do we have
this
to-
formula, can you just put the formula
I just did this.
No, not for now. Just make a sketch.
Wait.
Why intercept with that? So now you're going to do plot yourself, right?
No, you can do that.
Yeah. Wait,
How do we do that?
what were you asking? I'm confused.
I don't know. Do I basically run myself or do I have to? Can you program the Yeah. Isn't it? What? You have to do it by hand. Wait. When you do y minus y hat.
It's going to be the actual.
Does I find it?
Yeah.
This is the square root of regression line.
Oh, then I don't know.
Huh?
But that's how you find the result.
Oh no, this was also using
I don't like
Back to.
Okay. So,
I mean, I can.
what's our first step? Yeah.
Those are just so.
Oh, what's the equation?
So,
For your scatter plot.
put in your list of
I
names.
have a page right here.
Okay.
Like I did it, but I'm trying to read.
Yeah. Say that again. No, use the list.
Okay. And then
You took a picture of it.
go stat,
The steps.
count.
Yes, because Maddie we were picking on her because she didn't take pictures.
Whoa, you don't have to
And then make
make
sure
one on the
1
other.
and 2.
Yeah, I do.
how you remember that.
Okay. This is how you put it into the block. Okay, so then what do I do after that? Bars.
Oh, that's it. Got it.
Function. What did I do? I messed it up.
Oh.
I messed it all up.
Calvin's
I always need to turn around calculator. I found it this morning, but it won't turn
Oh
on.
my gosh. At the beginning of class, I said, who needs to borrow a calculator? Nobody raised their hands. All right.
Can I get this one?
Wait, no, then you go back to stat.
Yeah, edit, and then you go, yeah,
Why are you getting rid of it?
yep.
Wait. I'm about to do it. No! You missed it!
Way to go.
Minus.
All right. Hopefully at this point, I'll be right there.
No, that's, you don't have to.
You have your scatter plot done, at least. So your scatter plot should look something like that. For notes, do you have to make your sketch absolutely perfect? No, it's for notes to help you know what we're looking at. So when I make my sketch, well, I am going to make my X and my Y touch. But it'd be something like this. I have one way down there, one there. Got a couple of... So there's my scatter plot. It's not perfect, kind of looks similar. Okay. Do we remember how to make our residual plot? Kind of. I did give you the opportunity to take a picture of the steps for a residual plot. Now where did I put it? There it is. So I'll put them back up for a minute so that hopefully if you haven't made your residual plot already, you remember how to do it. Yes, take pictures, please.
She sent me a picture of it.
Did she send you the picture?
But I don't, if I already have a picture, why would I take a picture? What do we have for the live one? What do you need? You go. You put the equations. Oh, it's six.
Yeah, I know how to get rid of the block.
Your steps are good.
I understand my steps more than I understand.
Oh, your flash is on.
Same thing.
Like, no, like I've been at one Me too.
Oh, shit.
Why are we twice?
I don't know how.
I swear I turned it off earlier.
I didn't want for the blackberry.
So you go.
Yeah.
And then there's a blackberry.
Huh?
And I went straight for it.
Bars. The Y one. And then you You didn't explain anything.
Yeah, maybe one. I can show you.
Bro, I know he's so
Like,
Okay.
like, what is this? Like, right?
So I click shut. No. So look, here, right? And you want the Y1. So okay, yeah. Okay, so you go here, and then you're like, oh, you're gonna go get that, and then you're probably gonna read your then you're gonna click that.
Okay, so let's
I already did it, so I don't know what's happening. It's kind of so yeah. So and then you click functions, and then you click vibrate. Yes.
Hold on.
But you put it in the
Okay, so you have you just pulled four. You want to do another scatter?
Give me a minute.
Okay, then go to that one.
What?
The one that is on
Snore.
and then click bars. And then go to the
You don't have time to do all this.
and then click I got and then it puts it right there. Okay, and then it puts it in the while. And then it's like after you put it, it'll plug it. Wait, what did you get for show me your country. I think I burned the white. But when you're over there. Put it in the frequency. Let me try. Yeah. No. It's like in the most.
I'm sorry, where would you put them?
Right here.
No,
Like a welcome.
I don't want
Like a
kids
welcome.
with the snotty noses by my desk.
Like, well,
No,
come
thank
get a
you.
tissue, guys.
Wait, what did you put? Wait, okay. Oh, Molly, here you go. If you want to, I can show you. I'm just copying you. Ah! So that one is word. Is that what it's supposed to
Yeah. It just puts a line. That's not the receiving.
That's not your
You need to get one to. You go. She has a step. So then you go.
list
And
one.
then
Versus what?
so parentheses.
Donuts first. Thank you.
Sorry, donuts.
You know what?
All right.
So we just
I hate
switched
donuts.
how to fix
What?
it.
What about
All right.
peanut butter donuts?
What?
Peanut butter donuts.
She doesn't like
Did
any
they make peanut butter
Yeah,
donuts?
they do.
They make every flavor.
I don't like donuts. Donuts make me nauseous.
They're so good.
No. All right. Your residual plot should hopefully look something like that.
Wait, what? Wait a minute.
We have.
I don't know what I did.
All right. If it doesn't look like this, let's take a look for a minute.
Mine looks linear.
Then you're probably still looking at the original data.
What?
You're probably still looking at the original data.
So maybe I put the list in wrong?
No, did you do all your lists?
L1 through L4.
You need to graph L1 versus L4. If you still have L2, it's going to still look like the original scatter plot. Thank you, Noah. All right.
It sounds weird. And then
Any questions? Nate,
Yeah, my residual plot looks flipped. Like,
flip.
yeah, where yours is above, mine is below, and where yours is below, mine is above.
What did you put in for your least squared regression line?
I stored it in the EQ or whatever,
Oh, there we go.
so I have like a 17 decimals.
That is weird.
Mine did the same. Mine did.
Yeah.
I'm looking at my shirt. Gosh.
I'm so.
Very stressed.
I know.
The first ending. That's so bad.
Oh my gosh, I'm once you get the Y from your Y.
Yeah. I don't think so.
Alright, quiet back down, please. So, now we're going to look at some residuals. So we're going to predict the Giselle score for a kid who spoke his first word at exactly 1 year. Which, actually, you already have the prediction in the calculator, don't you? Because child 17 spoke his first word at 1 year, 12 months old. So what if we go into our lists? List 3 is all the predicted scores. And we want to find the 17th one. Oops, 17. Because child 17 did speak their first word at a year, 12 months old. So we get a predicted adaptive Giselle, what is it? Giselle adaptive score of 96.31. If you don't like doing it that way, you can put 12 in for x in your equation and get the prediction. But that's what list 3 already did for us. So 1 year is 12 months. And we know that we get our predicted scores from 109.87 minus 1.13 times x. So if you put 12 in for x, you should get the same thing. That's not what I wanted. 1.13 times 12, 109.87 minus that So we get 96.31, whether we use the list or the equation. Why is it so bright? Don't know.
You can turn down the bright.
I'm trying to, but it's not changing it much.
That's good enough, I think.
All right. So then we're gonna find the residual for this prediction. Again, you can use the lists. We're looking at child 17 because they spoke their first word at 12 months old. Or you can find the residual by taking the actual 105 minus the predicted 96.31. Residuals are actual minus predicted. Oops. 105 minus 96.31. We get 8.69. Now, you do need to be able to interpret residuals. Residual means what? Leftover, how far off our prediction was. Now, the thing that I notice with kids when they interpret residuals is that they mix up whether it means your prediction was above or below the actual, which to me, I don't quite get, but that's the most common mistake I see is kids mix up whether the predicted or was above or below the actual.
Is that an equal sign next to the 8.6?
Yeah. So for me, I would say something like when using the least squared regression line, and I'm going to abbreviate least squared regression line as LSRL, to predict, and this time we're predicting the aptitude score from their age when they spoke the first word. Score from age in months. I'm going to abbreviate months. The prediction now the prediction was the 96.31. So I would say the prediction is 8.69 below the actual. Sorry, my handwriting is too big. Below the actual. And what I said I see is the most common mistake is whether it's below or above the actual. And again, I think because we got a positive answer, kids always just write that it was above the actual. A negative prediction would result, a negative residual means you had a prediction above the actual. Hannah.
When it's R squared and it's asking us to figure out if it's negative or positive and we don't have a graph, how is it?
Your slope. So I had R squared. I square rooted it. I got 0.64, so then I have to think about whether it's a positive or negative. And my slope was negative, so that tells me that I have a negative linear relationship, so I made my R negative. All right. Any other questions before we move on to outliers? Hayden. You waited that long to ask for pencil? All right. So now we're going to look at what outliers can do. So just as a reminder, an outlier is an observation that lies outside the overall pattern of the other observations. There are two possible outliers with this data. We're going to identify those two outliers, and we're going to circle where they show up on our residual plot. So looking at just the data, anybody have an idea on what the outliers might be? Which kids might be outliers? No? All right. 18. Who said 18? 18 is an outlier. Almost, well, 3.5 years old before they spoke their first word, where the rest of them were under, well, except for this kid. The rest of them were under 2. There's one other outlier. Nate?
2?
No, it is not 2. Not 11. Did you say 9? 9? No. Good try, though. Could you imagine having a 7-month-old child who's speaking to you?
What?
Like, my oldest spoke at 9 months old, but I don't know. It's a 7-month-old. That's crazy. All right. 19's the other outlier. Yeah. Well, that's why I was like, did you say 9? I was hoping you'd be like, no, I said 19. So 19 is an outlier because their age is towards the older end, but their aptitude score is the highest, right? Yeah. So even though they weren't super young, like number 11 here, they had a really high aptitude score later in life. So 18 is an outlier and 19 is an outlier. So 18, child 18, and child 19. And then we're going to circle them on our residual plot. So child 19, I'm going to remind you guys also of something cool about the calculator. Let's see if we go back to our graph. So I'm pretty positive that these are my two outliers on my residual plot. They kind of stick out from everything else. So remember, if you hit trace, it'll actually allow you to go through the dots and figure out. Of course, it kind of jumps around, so we have to just go until we find the one. That's child 18, and I know that because X is 42. So child 18 is this guy way over here on my residual plot, which then means, yep, that guy is child 19 way up at the top. Another way to think about it is because when we make our residual plot, we're still using age as our X. So 18 with an age 42 is definitely going to be the last guy way out there. And then 19, his actual score is going to be much different than his predicted, so his residual should be way above or way below. Can I flip back to my other page now? All right. So we're going to figure out which of these outliers has a bigger effect on our least squared regression line. So child 18, and here's another cool thing about the calculator. On my residual plot, if I have, this is child 19, is at age 17, the Y value is my residual. So child 19 has a residual of 30.34. And again, if you don't like using the calculator, You can put 17 into your equation for x, solve for your predicted, then subtract from the actual. And child 18 has a residual of negative 5.41. So one residual is much larger. Why is it much larger? I kind of touched base on this a little bit already. What's different about child 19 versus 18 if we look at the raw data?
They have a really high score.
Say that again,
They have
Hayden?
a really high score.
They had a really high score, but their age was in, I don't want to say normal, but it was in nicely in the middle of all the other ages. Where 42 was way at the end of the age, it was our highest X value. So this kid had a decently low X, but a really high Y for the actual, where this was a really high X. I don't know if I'm making sense. Like, this kid is so much older than all the others, where this kid is about the same age as all the other kids, but his Y, his aptitude score, is much different than the rest of them. So his residual is going to be much bigger. And let's see if I can paraphrase that. So number 19 has an aptitude score much higher than other kids, approximately his age. And when I say his age, I mean for age of first word. And I don't know why I made it him, but I did. Nate.
Does that mean that the Y value has a greater effect on the residual than the X value?
We're going to get there.
Okay.
So we're going to figure out which one is more influential. That's the whole point of looking at the outliers. So child 19, his X is kind of in the middle of the pack, but his Y value is very different. Where child 18, his X value is very different, but his Y is kind of in the middle of the pack. So we're going to see whether having an outlier in the X or the Y direction has more impact on our least squared regression line. So we're going to remove them. So we're going to look at our least squared regression line. Then we're going to remove one of the outliers, see how it changes. And then we're going to remove the other outlier, but put the other one back in and see what happens. So with all the data, the least squared regression line was 109.87 minus 1.13 times x. So we're going to remove child 19 first. And we're going to then find our new least squared regression line. So we're going to go into our lists and we're going to edit them. Now we're only going to mess with list 1 and list 2. So that's the lists we use to find our least squared regression line. And hopefully if you put them in order, we can just scroll down until we have 19 in the parentheses. And if you don't have them in order, we're looking for the kid that's 17 with an aptitude score of 121. So highlight the 17. Since we're only getting rid of this single piece of data, we use the delete. And it just takes out that piece of data. And then we got to make sure we get rid of the corresponding aptitude score of 121. And we're going to hit delete. Good? Then we're going to go back and we're going to get our new least squared regression line. So we're going to go stat, over to calc, and we're going to choose number 8. Should hopefully still say list 1 and list 2. Go down to calculate. And my y-intercept is 109.31, and my slope is negative 1.19. 31. I've really rounded. I said, okay, well, that 4 is close enough that if it's a 5, I'd round up. Well, if I look at the 6 behind the 4, it does round it to a 5, and the 5 then rounds it to a 1. But that little decimal really isn't going to be the biggest thing that we need to focus on. But that's how I thought through that one. Sorry, my 9 looks kind of like an A. There we go. Everybody good on that? So our y-intercept didn't change a whole lot, and really either did our slope. Didn't change a whole lot. So now we're going to see what happens when we remove child 18, so the 42 and the 57. So this time when we go in, because I need to put child 19 back into the data set. So when I go into my lists, I'm going to edit. I want to go to the 42. But instead of hitting delete, I'm going to type over 42 and put child 19 back in. And he was 17 months old when he spoke his first word. So I highlighted the 42, and then down here I typed 17 in. When I hit enter, it replaces the 42 with the 17. And then I want to replace the 57 with 121. So I highlight the 57, and then I type 121 and hit enter. So now child 18 is removed and child 19 is back in my data. And then I'm going to find my least squared regression line this time. So with child 18 removed, my y-intercept is 105.63 and my slope is negative 0.78. .63 minus 0.78 times x. God bless you.
Thank you.
Alright, so which child 19 or 18, had a bigger influence on our least squared regression line? 18. So when we removed child 19, our y-intercept didn't change a whole lot, either did the slope. When we removed 18, our y-intercept changed quite a bit, and our slope really changed. So child number 18 had more influence. And the reason why is because child 18 was an outlier in the x direction. So remember I talked about how his age, he was way at the far end of our x values. All the other x's were 26 or below. So child 18 was almost 20 higher in our x. So when you have an outlier in the x direction, it's going to have more influence on your least squared regression line. Child 19 was an outlier in the y direction because his y value didn't fit with the rest of the data. And so you want to look for those outliers in the x direction. 18 is an outlier in the x direction. questions, I will tell your Nate.
Why does the X affect more than the Y?
I'm trying to think of how to say this without. I don't know if this will help, but this is how I tend to think of things. I'm a visual person, although apparently there's a new theory that, you know how we've taught you guys, like you're a visual, auditory, or kinesthetic learner, that those things aren't actually true. But I like to see things. They make more sense to me, okay? So if I have my scatter plot, and I've got most of my data, and this isn't that data per se, I'm just going to kind of use so I have this is my outlier in the Y direction. He's much higher than the other pieces of data around the same X value. So he's an outlier in the Y. This is my outlier in the X. Okay? So when I have this piece of data here, it's going to create my least squared regression line has to go towards it. And so he kind of pulls the least squared regression line towards him. Where if I get rid of him, my line's going to change really drastically. But with this guy, my line's there, and it's the orange one, let's say, and I get rid of him, it's not going to change my line a whole lot. So it's the outlier in the X is going to pull your line towards it, and so it's going to change your slope a lot more than an outlier in the Y. Did that help?
Yeah.
Okay. Any other questions? No? All right. So I have some true-false. I have talked about these in other lessons. I want you to read through them, put whether you think it's true or false. Stop before you get to the whole regression to the mean thing. I'm going to talk about that. That's kind of a side note. Comes up every once in a while, but it's really not a huge thing. You're playing 8-ball?
I was doing that for like a second.
That really hurts, Noah. Really hurts. She takes pictures for you. Important things. Probably needs help.
What's me effect?
As a kid.
Oh my god. Wait, what you get again? That's this thing.
So the actual is 105. The predicted from my squared regression line is 6.31. And the definition of a residual is your actual piece of data minus your predicted.
The correlation table versus
Yes.
it doesn't
The hat means predicted.
I know.
No, you're supposed to know this stuff. Yes. Wait, really?
That's you've taken psychology too.
Oh my god. Yeah.
Yeah.
This is proof causation.
Correct on Monday. All right, A is true or false. How many people say true? Show of hands. How many people say false? And the rest of you just think because you don't want to raise your hand? Thanks. Alright, this one is true. Knowing which variable is explanatory and which one is response is important for regression. B, correlation and regression lines describe the strength of any scatter plot. How many of you say true? How many of you say false? The false people have it. Correlation only tells you the strength of linear relationships. I did get you there. And scatter plots aren't always linear. You can have curved and cluster. Those are the other two common forms. Yes, correlation only gives you strength of linear relationships. And the weird thing is, if you have data and you don't look at the scatter plot, you could actually have a scatter plot that looks like this, like a parabola. And if you do linear regression on it, you can get it at R value really close to 1. That's why looking at the scatter plot is really important. Because if you don't look at the scatter plot and you just did linear regression, your R could say it's really strong, but it's actually not. Okay? C, correlation and regression are resistant to outliers. How many of you say true? And false. Thank goodness. I was going to say, if anybody said true after the whole lesson I just did, that would really hurt my feelings. Maybe that's why Noah walked out, right? He was playing 8-ball instead of listening to me. All right, he did? Okay, good. And then D, a high correlation means that one variable is causing changes in another. How many of you say true? Hannah? I'm very disappointed in you.
What?
How many of you say false? Hannah? Correlation does not imply causation. Killing me. You should. If any of you have taken my husband's class, you have heard that many, many times.
I was in math though.
Those two subjects are very overlapped. All right. Regression. So I guess to add to that, correlation says there's an association between two variables. It does not tell us that one variable causes the result in the other. It just tells us that there's a relationship. And then the regression to the mean down here. I have never seen it come up on the AP exam, but that doesn't mean it can't. So I do want to talk about it. It's more of a definition type thing than it is something you actually see in problems. But like I said, it is something that could show up, so I do like to talk about it. It's not going to show up on my test for you guys, but I do want to talk about it. So when your correlation isn't R equals -1 or R equals +1, that should say or, not of. Sorry. The predicted value of y is closer to its mean y bar than the value of x is to its mean x bar. And this is called regression to the mean, because y values regress or get closer to their mean. Molly. Not on my test for you, no. And I've honestly never seen it. They release all the free response questions every year to teachers. They don't release the multiple choice except for every 4 years. And I do look at them so that I make sure I'm teaching to what you guys will see on the test. I've never seen this concept on the AP exam. That doesn't mean it won't ever show up though. So I do like to at least give you the definition, but no, it will not be on my test. Any other questions? All right, so some of you I noticed did the homework, the last homework assignment on Friday. If you did not do that, that's your homework tonight, since we just now finished that unit lesson. I don't see you tomorrow. Wednesday when I see you, I'll have a review packet for you. And then you'll have a long weekend. We'll review again on Monday. Test will be on Tuesday.
Wait, it's not.
Okay?
No, we're
No.
just you in the bathroom. She moved it to Tuesday.
Yeah, well, because I just finished our last set of notes, so there's no way I could review today too and test you on Wednesday. That's just me.
So the test.
I actually want you guys to do well in my class. believe it or not. I know, right? Yes, so it'll go on next quarter's grade because we're taking it next quarter.